In this video, we'll be completing the section 1.4 notes, linear equations and two variables. So we're kind of going back. We're starting with straight lines again, and we're going to look at the other two equations of lines that we didn't look at in section 1.3. So first we're going to define slope. The slope of a line through x1, y1, the first point, and x2, y2, the second point, is y2 minus y1 over x2 minus x1. And usually they use the letter m to represent the slope, and I don't know why. I don't know. I haven't heard from any other math teachers why either. They describe this as the change in y over change in x. This is the shorthand for change that we use. It's delta in Greek. So this is change in y over change in x. Hopefully this is ringing a bell. And another way of thinking of this is rise over run. So rise, the change in y, is how far up the slope is. Run is how far you go to the right with the slope. So slopes can be positive or negative. So a positive slope would go up and to the right, and a negative slope would go down and to the right. So we always think of going to the right. Reading a graph from left to right is how we think of it. So over here, there's some pictures so you can see what the different slopes look like. So here, these slopes right here, we've got slopes that are more steep, negative 2x, kind of normal, and then less steep, negative 1/2 x. These are your negative slopes. They go down to the right. These slopes over here, they go up to the right. Those are your positive slopes. Right in the middle, we have y equals 0. This is your 0 slope. And then they didn't write it, but right here, this is your x equals 0. And this is your undefined slope. So they would say the slope doesn't exist, but only because it's undefined. It's straight up and down. Okay, so find the slope between the two set of points. We're just going to subtract the x's, subtract the y's, and we're going to make sure that we're consistent with the direction that we go. So the y's go on top, so y2 minus y1, negative 2 minus 4. x2 minus x1. So the top is negative 6. The bottom is 2, and that gives us an answer of negative 3. And we would have gotten the same answer if we had subtracted the other direction. If we did 4 minus negative 2, we would have gotten positive 6. And then negative 3 minus negative 1 is negative 2. And positive 6 over negative 2 still would have given us negative 3. So you get the same answer regardless of which direction you go when you subtract. So the slope between those 2 points is negative 3. 7 minus 7. 5 minus negative 3. This gives us 0 over 8. And that is a slope of 0. Anytime you have 0 divided by a number, that's just 0. And then over here, we have 8 minus 5. Negative 3 minus negative 3, which gives us 3 over 0. And anytime you have a number divided by 0, this is just undefined. All right. So next we're going to talk about a type of linear equation you might not have seen before. This might actually be new, and this is the point-slope form. So the way that you write it is you write y, this is a variable, minus a y coordinate for a point, equals the slope times x, the variable, minus the x coordinate for a point. And it sounds like what it is. You use this form if you have a point and a slope. Not very common in a pre-calculus or an algebra class, but very common in a calculus class to write your answer and leave it in this form. So in this class, we won't be doing that, but later on, if you take calculus, you might. So it says write the point slope form of the line that goes through these points. So first we're going to find the slope. So 3 minus 4 over 2 minus negative 1. 3 minus 4 is negative 1, and that's 3. Okay, so we do the variable y, and then here it's minus y1. You'll notice that that says positive y1, so it's just the opposite sign. So opposite sign of 4, and then we write our slope, and then we write the variable x, and then it's the opposite sign of the x coordinate. So the opposite sign of negative 1 is positive 1. So this is one answer that you could have, because you could use this point, or you could use the other point. Y minus 3 equals the slope x minus 2. So you'll notice I did the opposite sign of each of the points. Okay, so we can graph those 2 points, negative 1, 4, positive 2, 3, and you can see that that slope did happen. We went down 1 to the right 3, down 1, right 3, down 1, right 3. Now, if you're following the slope, down 1, right 3, we always go up or down and to the right. If you run out of room, then you can do the opposite pattern and go to the left. So down 1, right 3, down 1, right 3. The opposite pattern would be up 1, left 3. Up 1, left 3. Okay, so there's that one. Now for the next one, we've got an equation of a linear equation that's written in point slope form. We're going to graph it. So first we have to recognize what the point is that they gave us. They gave us negative 5, negative 4. And so it's going to feel similar to graphing slope-intercept form. In slope-intercept form, you usually start with the y-intercept and then you do the slope from there. So here, we're not going to have the y-intercept. We're going to have something else, some other random point. Negative 5, negative 4, left 5, down 4. And then from there, we do the slope. So the slope for this is negative 2. I want this to be a fraction, so I can think of this as rise over run. So anytime you want to make a whole number a fraction, you just put it over the number 1. And so this rise over run would be down to right 1, down to right 1. So I'm going to go down to right 1, down to right 1. I ran out of space, so I'll do the opposite. Up to left 1. And that's what the equation would look like. The line would look like when you graph it. Okay. Now we're going to actually review slope-intercept form. So y equals mx plus b, where the m is your slope and the b is your y-intercept. So we've got 3x plus 5y equals 15. And we're going to get it into y equals mx plus b form. So the first thing we want to do is subtract the 3x, because in this form the y is all by itself and the x and the number are on the other side. So we got 5y, I'll write the x first and then the number, negative 3x, positive 15. And then to get the y alone, I'm just going to divide by 5. So y equals negative 3/5 x plus 15 divided by 5 is 3. And so I'll start with my y-intercept. That's where the graph crosses the y-axis. So positive 3. So my y-intercept is 3. And then I have to go down 3, right 5, down 3, right 5. And I don't really have space to do this, but if I was going to keep going, I'd go down 3, right 5 like that. But I ran out of space, so I'll do the other direction. It's not very straight. Close enough. Okay. Find the equation of a line in slope-intercept form with the point that goes through the point, -2, 3, and has a slope of 1/2. So this is an x and a y coordinate. It has a slope of 1/2. To be able to write an equation of a line, you have to have something for m and something for b. So that's where we need the numbers to be. So these are the numbers I have to plug in. I'm going to go ahead and plug them in right now. 1/2, -2. Okay, so I have enough information to solve for b. And then once I solve for b, I can take the b value and the m value and write the actual equation out. So 3 is 1/2 of a -2 is just -1. And then I'll move that 1 to the other side of the equation. Okay, so my b value is 4, my m value is 1/2. So my equation is 1/2 x plus 4. Okay. So here we're kind of summarizing what we've looked at with linear equations, linear functions. We have 3 different forms. We have the standard form where x and y are on one side and the c value, or the plain number, the constant, is on the other side. We have slope-intercept form where you have the slope and the y-intercept. And we have point-slope form where you have some point that isn't the y-intercept, and then the slope. So vertical lines have no slope. They can't be written in slope-intercept form or point-slope form. That's x equals a number. That's how they're written. All lines can be described with an equation in standard form. So standard form is just writing the x plus the y equals the number. So yeah, we can do that. For any constant k, y equals k is a horizontal line, x equals k is a vertical line. Yep, we knew that. If you know 2 points, you can find the slope. Makes sense. If you know the slope and a point on the line, you can use the point-slope form. If the point is the y-intercept, use the slope-intercept form. That's helpful. Final answers in this course are usually written in slope-intercept form or standard form. I would X that out. I would only do standard form if they told me that's what they wanted. Final answers in calculus are written in the point-slope form, but not this class. In this class, we're going to do slope-intercept form. Okay, so here, this problem is crazy. This example is crazy because they want us to take this and they want us to write all 3 forms. So you can kind of see the connection between them. So the first thing I'm going to do is find the slope because 2 of the forms need the slope. So I'm going to find the slope between these two. 4 minus 2. 1 minus -5. I get 2 on the top, 6 on the bottom, and 2 over 6 can simplify to just be 1/3. Okay, so the slope is 1/3. Now, in point-slope form, that one's going to be probably the easiest. I can use either of those points and plug in the slope. So I can do y minus 2 equals 1/3 x plus 5. That's if I use the first point. Or I can say y minus 4 equals 1/3 x plus 1. Either of those answers is fine. Okay, slope-intercept form is probably the next easiest because all I have to do from this form is take whatever number is with the y and move it over, and also get rid of the parentheses. So both of these problems are going to give me the same answer. I'm going to choose to do this one because it has a 1 in it. And these ones just have bigger numbers. I don't know. That one seems easier to me. So y minus 4 equals 1/3 times x plus 1. I can't add the 4 over first because I can't add it to something when there's parentheses there. So the first thing I'm going to have to do is get rid of the parentheses by distributing the 1/3. So y minus 4 is 1/3 x plus 1/3. Okay. And then I can go ahead and I can add the 4. Okay, so I have y equals 1/3 x, and then I've got 4 plus 1/3. So if you think about it, how many thirds 4 would be? What number divided by 3 is 4? That's 12 thirds. 12 thirds and 1/3 is 13 thirds. If that made your brain feel upset, you can always do it on a calculator. 1/3 plus 4, turn that into a fraction, 13 thirds. So all I was saying was that 4 is the same thing as 12 thirds. That's how I did it in my head. Okay, so there's the answer in slope-intercept form. And then the last one is the standard form, and standard form has some extra rules. So standard form says you can't have any fractions. So we're going to have to get rid of the thirds here. And it also says that the x and the y have to be on the same side, and the x has to be positive. So no fractions in the whole thing, x and y on the same side, the x has to be positive. Okay, so the first thing I'm going to do is I'm just going to take the answer from slope-intercept form. And because my fractions are in thirds, I'm going to take this entire equation and I'm going to multiply it by 3. So 3 times y is 3y. 3 times 1/3 is just 1. You can write 1x or you can just put x. They're the same. And then 3 times 13 thirds is just 13. Okay. Now I could subtract the x over, and then I'd have the x's on one side, the x and the y on one side, and then a 13 on the other side. But my x would be negative, and that's a problem. So I have to do the more complicated thing and subtract the 3y over here, and then subtract the 13 over there. So I have negative 13 equals x minus 3y. It's backwards. The x's and y's are on the right, the numbers on the left. It's technically standard form, but if you don't like that order, you can just flip it around. So this is more proper because the x term is positive. You could have subtracted the x over here, but then your x term would have been negative and it wouldn't have quite been standard form. Would have been close, but not quite. Okay. Parallel lines. Hopefully this is familiar to you as well. Two non-vertical lines in a coordinate plane are parallel if and only if their slopes are equal. And really, vertical lines have equal slopes too. It's undefined and undefined, so they're being silly there. Okay, find the equation of the line through the point 2, 4 that is parallel to this other line over here. Well, if it's parallel, it's going to have the same slope. So our new line is going to have a slope of negative 1/2, and then it's going to have an x-coordinate of 2 and a y-coordinate of 4 at some point. And typically we write our problems in y equals mx plus b. So I'm just going to go through and plug this in. I just need to know what my b value is so I can write my equation. So 4 equals my slope times my x-coordinate plus b. Negative 1/2 times 2 is negative 1. And then I can get b alone. I get b is 5. So the equation of the line that is parallel to negative 1/2 x plus 9 is negative 1/2 x plus 5. Same slope, so they're parallel. Okay. Last problem. All right, perpendicular lines have slopes, M1 and M2, and M sub 1, M sub 2. They're perpendicular if and only if, when you multiply the two slopes together, you get -1. This means that the slopes are negative reciprocals. Oops. Right, negative reciprocals. So if we look at these two perpendicular lines here, this line has a positive slope, so the slope would be like A over B. And this slope is negative, and for it to be the negative reciprocal, it would be negative B over A. So reciprocal means that you flip the fraction, negative means that the signs are opposite. So that's how you can tell just by looking at the slopes that the two lines are perpendicular. So this says find the equation of a line that is perpendicular to this line in standard form and contains this other point. So the first thing we need to do is we need to find the slope of that line so that we can figure out what slope is perpendicular to it. So I've got 3x minus 4y equals 8. I'm going to get this into y equals mx plus b form, or I'm going to start doing that anyways, so I can figure out what the slope is. So I'll subtract the 3x to the other side. Negative 4y equals negative 3x and a positive 8. And then to get the y alone, I need to divide by negative 4. Okay, so negative over negative is positive, and technically I can stop there because I know what the slope is, but I don't like leaving this unfinished, so I'm going to keep going. Okay, so the slope of one line is 3 over 4, so that means that the perpendicular slope is negative 4/3. Change the sign and flip the fraction, negative reciprocal. Okay, and then we have an x and a y coordinate, and we just have to find the b value. So y equals m times x plus b. 1 equals, so if I multiply these together, I'm going to take this whole number, I'm going to make it a fraction. Multiply the numerators, that's 8. Multiply the denominators, that's 3. Okay, so I have 1 minus 8/3. I want to minus the 8/3 over to the other side. 1 is 3/3. So I have 3/3 minus 8/3, which gives me negative 5/3. But just to prove it to you, 1 minus 8/3 is negative 5/3. Okay, so my perpendicular line is y equals negative 4/3 x minus 5/3.